All right, here we go with the topic solve linear equations. Number one, these are going to be two-step equations because this is seventh grade and seventh grade material at this point has you just do two-step equations. So remember that every time I solve one of these, the way that I show you, and I might show you more than one way for some of the equations, but if I show you one way for the equation, that's not the only way. You can solve things different ways. I'm going to show you what I think is the easiest way. So here we go. If you're solving an equation for a variable x, you're trying to say what x is that makes this statement true. The statement here is that 6 times x, take away 9, is the same value as 75. So 75 is worth the same as if I multiply x by 6 and then take away 9. So what value for x makes that true? I mean, if x is 5, it's not true because 6 times 5 is only 30, and 30 minus 9 is 21, and 21 is not the same as 75. So what number can we substitute for x that makes that true? Now, this is a multiple choice question, so you can kind of cheat and just plug in the answers and see which one works. But if you don't have multiple choice, you got to be able to solve these. So here's how you solve them. We're going to kind of work backwards. If I say that you're going to multiply x by 6 and then take away 9 and get some value, what is the reverse of that process? Well, you would take the value and add 9 and then divide by 6. What am I talking about? Well, it works like this. The left side of this equation says 6x minus 9. What I really care about is the variable x. And I want it to just say x equals, not x times anything, and not x times anything plus or minus something else. So I want to get rid of the times 6, and I want to get rid of the minus 9. So I have to do those one at a time. The first thing I'll do is I'll get rid of the minus 9. Well, how do I do that? Well, what if I add 9? What if I say 6x minus 9 plus 9? Well, 6x minus 9 plus 9, well, it just goes right back to 6x. If I have some number, and from that number, no matter what it is, no matter what 6x is worth, if I take away 9 and then add 9, well, I go right back to whatever 6x is, right? So I want to go ahead and cancel those out. That leaves me with just 6 times x. Now, you have to think about this equation as a balanced scale. I just added 9 to one side of the equation, so I have to do the same thing as to the other side to keep it balanced. So I will add 9. Now, you may have noticed I made a mistake in writing this problem down. It's not 75. It's actually negative 75. You can see in the problem. So I'll go ahead and fix that. Negative 75. So it's equals negative 75. And what is negative 75 plus 9? Now, if you're at negative 75 on the number line, you're all the way to the left of 0. You're pretty far to the left of 0. Adding 9 sends you back towards 0. So negative 75 plus 9 is negative 66. Then you return and put your equal sign. Your equal sign just comes down. So to both sides of the equal sign, I added 9. And I can do pretty much anything I want as long as I do it to both sides of the equal sign, as long as I treat both sides evenly. Like I said, it's a balanced scale. On one side of the scale, you had 6x minus 9. On the other side of the scale, we had negative 75, and it was perfectly balanced. Well, if we take a perfectly balanced scale and we change one side, we have to change the other side in the same way. So if I add 9 to the left side, I have to add 9 to the right side to keep it balanced. Now, you may have remembered that I said I was going to get rid of the minus 9 by adding 9, but I also wanted to get rid of the times 6 part. I don't want 6 times x. I just want 1x. Well, I'm going to go ahead and do the opposite of multiplying by 6, which is dividing by 6. And I write divided by 6 with a fraction, not the division symbol. So 6x divided by 6, and 6x divided by 6 is 1x, which we just write as x. Of course, if I divide one side by 6, I have to do the same thing to the other side. I just made this 6 times less, so I have to make the other side 6 times less. So negative 66 divided by 6, a negative divided by positive is a negative. 66 divided by 6 is 11. So one side of the equation says x, then I have my equal sign in the middle. The other side of the equation says negative 11. When you have your variable equals some number, that number is the solution. I'm saying that x is equal to negative 11. And we could go back to our original equation and plug it in, and we could see if that actually works. Let's do that. If x is negative 11, then 6 times x minus 9 equals negative 75. turns into 6 times negative 11 minus 9 equals negative 75. Now you notice instead of using a multiplication symbol, I just put the negative 11 in parentheses, right? Well, what is 6 times negative 11? 6 times negative 11 is negative 66. Okay, so 6 times negative 11 is negative 66. And then so negative 66 minus 9 equals negative 75. And that's true. Negative 66 minus 9 is negative 75. So it works out. Negative 75 does equal negative 75. We got a true statement, so it works. Had I plugged in the wrong number here, I would have gotten something that doesn't work. For example, had I plugged in, say, negative 12, which is answer C, 6 times negative 12 would have been negative 72. And negative 72 minus 9 would have been negative 81. It would have said negative 81 equals negative 75. And that's just not true, so we would have known that we'd plugged the wrong number in for x. Now, there's one more thing I want to point out about this problem before we move on. And the next problems we're going to do a little bit more quickly than this one. The other thing I want to point out is the following. You do it in this order for a reason, but you don't have to do it in this order. I added 9 to both sides, then divided by 6. Some kids want to know, well, what can I divide by 6 first? And the answer is yes, sort of. Let's look at what happens if I try to divide by 6 first. I'm going to start with 6x minus 9 equals negative 75. Let's say I try to get rid of the 6 first. I'm going to do the dividing by 6 part, which I did in orange up here. I did dividing by 6 in orange. Let's do that part first. Well, if I try to divide by 6 like this, I say divided by 6 and I divide by 6, there's a problem with this. I'm not dividing the negative 9 by 6. In order for me to treat both sides equally, I have to divide the entire side by 6. The right side got divided by 6. The entire right side is just negative 75. If I divide the entire right side by 6, I have to divide the entire left side by 6, which means everything gets divided by 6. Well, what happens now? 6x divided by 6 is 1x, just like it's supposed to be. But now I've got this negative 9 divided by 6 part, and that makes negative 3 halves. And that is equal to negative 75 divided by 6, which negative 75 sixths can simplify because 75 and 6 both divide by 3. So that becomes negative 25 halves. So this is true, and I could continue to solve this equation, but I've got these fractions to deal with. Is that fun? No. So doing it the other way helps not get fractions. Now, had you noticed that both this term and this term both divide by 6? If that happened, then you wouldn't have that big of a problem, but this also would need to divide by 6 to avoid getting fractions. So had I done it this way, I would have ended up with these fractions, and then I would have had to do the plus part, the adding part. Of course, I'm not adding 9 anymore like I did in the beginning. In the first equation, I added 9 because I wanted to get rid of the minus 9. Well, I don't have 9 to get rid of anymore. I have this 3 halves. So I have to add 3 halves, so plus 3 halves. And that leaves me with just x on the left side. Of course, if I add 3 halves to one side, I have to add 3 halves to the other side. So I get x equals, and what is negative 25 halves plus 3 halves? Well, negative 25 plus 3 is negative 22. So my answer is negative 22 halves. And negative 22 halves can simplify. Negative 22 halves is negative 11. So I do get the same answer, but it's just a little bit harder because I ran into these fractions. The bottom line is the reason I did it this way is I want you to know you cannot just divide this term by 6 and not this one. If you want to divide by 6 on one side, you have to divide by 6 the entire other side. It goes for multiplying also. If you ever want to multiply one side of your equation by something, you have to multiply every term on each side, not just the one that you want, but all of them. So multiplying and dividing, you have to do it to the entire thing, every term on both sides. When you're adding and subtracting, adding to the whole side is what we did. We took this whole side, we added 9 to it. Now it just so canceled out that one term, but it's not that I didn't add it to the whole side. Same thing would go for subtracting. So let's go ahead and do another problem. Remember, the answer was negative 11. I'll go through some more problems here. We'll probably go a little bit more quickly here. Again, another two-step equation here. 6x minus 6 equals negative 54. That says minus 6, so I add 6 to make it go away. Of course, if I do it to one side, I do it to the other. So now I get 6 times x. Just broke my pencil. So 6x. On the left side, negative 54 plus 6 is negative 48. So 6x is equal to negative 48. Notice that the equal sign just kind of comes straight down. Next, we're going to go ahead and divide by 6 on both sides. So go ahead and do that. Divide the left side by 6, the right side by 6, and x equals negative divided by positive is negative. 48 divided by 6 is 8. So the answer is x equals negative 8. We go back and we plug it in to make sure that we did it right. 6 times negative 8 minus 6 equals negative 54. We go ahead and check that out. 6 times negative 8 is negative 48. So negative 48 minus 6 equals negative 54. And last but not least, negative 48 minus 6 is negative 54. So negative 54 equals negative 54. That means we did it right. So we go over and we choose our answer, which was negative 8, and we move on. Next problem. Which of the following statements describes a correct method for solving this equation? So let's go ahead and read through these. First, subtract 3x from both sides of the equation, then divide both sides by 2. So you clearly want to subtract, but what do you want to divide by? You want to divide by the 3 at some point, because it says 3 times x. There's no reason to subtract 3. That doesn't get rid of the 3. The only thing that gets rid of the 3 is dividing by 3. Just like on this last problem, to get rid of this term, I added because we were subtracting. To get rid of that 6, I had to divide because this 6 was being multiplied. So you have to do the opposite of what's going on. In our new problem, the 3 is being multiplied by x. So the only thing that's going to get rid of that 3 is when we divide by 3. This 2 is being added, so the only thing that we're going to do to get rid of this 2 is subtract. Now, this equation also has an x on the right side. So the one thing that you always have to do when you're solving an equation for a variable is get all the x's on the same side. Let's go ahead and write this equation down, and we'll go through it, and then we'll choose our answer. If you have 3x plus 2 on the left side, and that is equal to 5x on the right side, you can't just get rid of the 2 and divide by 3 like we did on the last problems, because the last problems didn't also have x's on the other side. Our first problem and our second problem looked very similar. It was something times x plus or minus something else equals something else, period. Something times x plus or minus something else equals something else, period. And that something else on the other side didn't have an x attached. This new problem does. 3 times x plus 2 equals 5 times x. You can't solve an equation if you have variables on both sides of it. So what I'm going to do is I'm going to have to get rid of either the entire 3x or the entire 5x. I always like to get rid of the one that has a coefficient that's less than the other. Since 3 is less than 5, I want to get rid of the entire 3x. Now, there's a difference between just getting rid of the 3. Like I said a minute ago, I can't get rid of the 3 by subtracting 3 because it's being multiplied. But like A says, I can subtract the entire thing. What if I subtract not just 3, but 3x? If I do that, the whole 3x cancels out. And of course, if I add or subtract something from one side of the equation, I have to do it to the other side. So I subtract 3x on the other side as well. So 3x's are gone from the left side, and all I have left is positive 2. So the positive 2 comes down, my equal sign comes down, and 5x minus 3x is 2x. Now, does it make sense why you want to divide both sides by 2? Sure it does, because it says 2 times x. And now I want to get rid of this 2 by dividing by 2. 2 divided by 2 on the left side is 1. 2x divided by 2 on the right side is 1x. So we have 1 equals x, and that's our solution. And I could go back and I could plug it back into the original problem. 3 times 1 plus 2 equals 5 times 1. Let's see if that checks out. 3 times 1 is 3, plus 2 equals 5 times 1 is 5. 3 plus 2 is 5, so 5 equals 5. That's true. We did it right. So while this looks like they're trying to trick you by doing a subtract one of these and then divide by the other, you're actually having to do exactly that thing because there's x's on the other side. Let's read what these other ones are. Divide both sides of the equation by 5. Let's try that. Let's just see what happens if I divide both sides of that equation by 5. If I start off with 3x plus 2 equals 5x, if I divide both sides of this equation by 5, on the right side, the 5's cancel out and I'm left with 1x. That's good. But on the left side, what happens? 3x gets divided by 5. So 3 divided by 5, so 3/5 x. And 2 gets divided by 5, so plus 2/5. Well, 3/5 x plus 2/5 equals x. Now it's not very clean anymore. Next it says add 2 to both sides, and that doesn't do anything because this isn't even a 2 anymore. It's 2/5. So this is clearly wrong. If I went to add 2 next, I would just have plus 2 on that side, plus 2 on that side. It would be 3/5 x plus 2 and 2/5 equals 2x, equals x plus 2. So that doesn't do any good in getting us to solve it. That is all bad. This is a no-no. The first thing you should try to do is get the x's all on the same side. You can't have x's on both sides of the equation. If you do, you have to eliminate one of them. Up here, we took this 3x and we said, hey, you got to go because there's x's on the left side, there's x's on the right side. We can't have both. We decided to eliminate the 3 x's on the left, and that solved it. Let's move on. Number 4, solve the following equation using the distributive property. So this equation uses the distributive property. Let's go ahead and do this one. 41.4 equals 3.6 multiplied by the sum of x and 4.5. Now, how do we solve this one? I'm going to give you 2 ways to solve it. First is we can actually distribute. So let's go ahead and do that first. A lot of kids like to distribute as soon as they see parentheses and a number in front of it. They like to distribute. It's their default thing. And a lot of times that works out to the best. So let's go ahead and do that. 41.4, I'm going to bring that down. There's no parentheses over there. That equals 3.6 times x, which is just 3.6x. And then 3.6 times 4.5. You've got to make sure to multiply by both terms. So we're doing 3.6 times 4.5. Now, it doesn't matter if you use a calculator for these. It's okay. I'm not saying that you should be able to use any one of those like equation solving calculators. That kind of defeats the entire purpose and you're not going to learn anything. But if you multiply, I don't know why I'm putting that in there. If you do 3.6 times 4.5, that's not like one of those ones I expect you to memorize. You get 16.2, so plus 16.2. All right, next step. Now we are at a regular 2-step equation, just like our first 2 problems. I want the x's on one side by themselves. I want 3.6x without the plus 16.2, so that I can simply divide by 3.6x to get the answer. How do I get rid of plus 16.2? I subtract 16.2. If I do it to one side, I have to do it to the other, so minus 16.2. So I've got my 41.4 minus 16.2, and I get 25.2. Now you notice I didn't actually do 41.4 minus 16.2. I did negative 16.2 plus 41.4, and that's the exact same thing. So you get 25.2 equals 3.6 times x. Okay, moving right along. Next up, let's go ahead and divide by 3.6 on both sides so that we don't have 3.6 times x. When I divide the right side by 3.6, I just get 1x. Next, I'm going to go ahead and divide the left side by 3.6. So I've got the 25.2, and I divide by 3.6, and that equals 7. So x equals 7. Now I'm going to plug that back in, but first I want to show you a completely different way to do this problem. Let's go ahead and start it back up from the beginning. 41.4 equals 3.6 times the sum of x plus 4.5. There's a way to do this problem in just 2 steps, not 3. And here it is. What if I right now said, I don't want 3.6 times this set of parentheses. I just want the set of parentheses. Well, what I could do is I could divide both sides by 3.6 right now. Why does that work when I made such a big deal out, oh, you have to divide everything by 3? Because this set of parentheses is like one thing. Imagine we had a variable, and that variable was different from x. Let's say it was n or y, whatever. Let's go with y. What if I told you y was equal to 4.5 more than x? That could rewrite this side of the equation as 3.6 times y, because y is x plus 4.5. If this said 3.6 times y, then when you divide it by 3.6, you would just be left with y. Well, in this case, I'm pretending that y is x plus 4.5. This is a self-contained thing in parentheses. So when I divide by 3.6, that 3.6 goes away, just like the 3.6 goes away when it's multiplied by a single variable. It's a single value. That value just happens to be represented by two terms in a parentheses. You're multiplying that single value by 3.6. So when you divide by 3.6, you're left with that single value represented by the parentheses. So we go over to our calculator and we say, okay, what's 41.4 divided by 3.6? Now this could work out really ugly, but this one happens to work out okay. It's 11.5. So it ends up being 11.5 equals, and then since that's gone, we just have what was in the parentheses, which is x plus 4.5. So x plus 4.5. This blue pencil does not like me. I'm going to switch over to purple. So x plus 4.5. Now I'm going to go ahead and do the second step, which is to subtract 4.5 from both sides, because I just want the 1x. And 11.5 minus 4.5 is, you guessed it, 7. And on the right side, we only have the 1x left, so we're done. So that's two steps. Divide by 3.6 and then subtract 4.5. So if you have an equation where there's a distributive property that could be used, you don't always have to do it. If you divide by that number, then what you're left with could just be 1x already, and then you can get rid of the thing you're adding or subtracting, and you'll have your answer. Let's keep it moving right along. This is just like the first couple of problems we did. It's a number times x plus or minus another number equals 70. So let's go ahead and knock it out real quick. 11x minus 4 equals negative 70. So I'm going to go ahead and add 4 to both sides. That makes 11 times x equals negative 66. Now I divide both sides by 11, and x equals negative 6. Next up, 5x minus 9 equals 36. Let's do another one. Do it right here. 5x minus 9 equals 36. Go ahead and add 9 to both sides. 5x then is what's left, equals 45. Divide both sides by 5, because I don't want 5x, I want 1x. And I get my 1x equals 45 divided by 5, which is 9. Another real simple one, 4x minus 6 equals 18. Go ahead and do that one. Step 1, get the 4x's by themselves by adding 6 to both sides. 4 times x equals 24, because the 6's cancel each other out. The minus 6 and plus 6 make 0. 4x divided by 4, and 24 divided by 4, x equals 6. So again, 4x minus 6 plus 6 makes 4x plus 0. 4x plus 0 is just 4x. If you do it to one side, got to do it to the other. 18 plus 6 is 24. Divide both sides by 4, because you don't care what 4 times x is worth. So you just want 1x, so 4x divided by 4 gives you that 1x. If you do it to one side, got to do it to the other, and there you go. Keep it rolling right along. 7x minus 20 is equal to 29. So 7x minus 20 is equal to 29. We're going to go ahead and add 20 to both sides because it says minus 20, and I want to make it cancel out. So we'll go ahead and do that. 7x minus 20 is equal to 29 plus 20 on both sides. And I get 7x equals 29 plus 20 is 49. Next, I don't care what 7 times x is. I just want 1 times x. So I divide both sides by 7. And x equals 49 divided by 7 equals 7. Another one, 15x minus 36 equals 54. 15x minus 36 equals 54. Plus 36 plus 36. Got to do it to both sides. That leaves me with 15 times x equals 54 plus 36 is 90. Go ahead and divide both sides by 15. And x equals 6. And last one more super easy one, just two-step equations. 6x minus 3 equals negative 63. So 6x minus 3 equals negative 63. I don't want it to be minus 3 next to my 6x, so I will add 3 to make it go away. If I do it to one side, I have to do it to the other. And I get 6 times x equals negative 60. Negative 63 plus 3 is negative 60. Divide both sides by 6. And I get x equals negative 10. And there we go. That's it. I my